All right, welcome back. Hononegah Honors. Algebra 2, Section 10.4 is the probability of disjoint and overlapping events. When you consider all the outcomes of either two events A and B, you form the union of A and B, as shown in the first diagram. When you consider only the outcomes shared by both A and B, so that would be the intersection of A and B, and then the union of the intersections or two events, or is it called a compound event, which basically A or B. And we'll talk a lot about A or B a little bit today. So finding the probability of A or B, you must consider the outcomes. If any are considered A and B, the two events are overlapping. When they have one or more outcomes are common, as shown in the first two diagrams, two events are disjoint or mutually exclusive. When they have no outcomes in common, that's the third diagram. And here's the big thing you want to get out of this, and I'm going to start at the bottom of disjoint events, A or B, meaning A has nothing to do with B. And so if you want the probability of A or B, you're going to add. So anytime you have an or situation, you're going to add the two probabilities together. Now, if you have A or B and some of the events are overlapping, then you have to subtract anything that's in both the probability of A and the probability of B. So you got to subtract anything that's overlapping in the two. Two six-sided dice are rolled. What is the probability that the sum of the numbers is a multiple of 4 or is a 5? So a multiple of 4, so I'm going to circle the multiples of 4. So we got multiples of 4, multiple of 4, and a multiple of 4. And so there are 1, 2, 3, 4, 5, 6, 7, 8, 9 multiples of 4 out of the 36 possible rolls. Remember, we're using the word or, so we're going to add, and now we have the probability that you're actually going to get a 5. So there are, I'll circle it, 4 ways of getting a 5. And so 13 out of 36, that does not reduce. So 13 out of 36 is the probability that you'll get a 4 or a multiple of 4 or a 5. Cards now, and you have to kind of understand cards a little bit in order to answer this question, but a face card is a jack, a queen, or a king. And so there are 4 of each of those. So we're talking about 12 face cards out of 36. Now, spades, there are, it's an or situation, so there are 13 spades. I don't know why I put 36, probably because of the dice roll on the last one. So 12 out of 52 cards. 13 out of 52 cards are spades. Now, there are 3 cards in the deck that are both a face card and a spade. Okay, the jack of spades, the queen of spades, and the king of spades. So we have to subtract the ones that are being counted in both the probability of A and the probability of B. So grand total here, we end up getting 22 out of 52, which reduces to 11/26. So again, if you take the probability of A or the probability of B, and if there's something that happens to be in both A and B, you got to subtract that probability as well. Out of 200 students in the senior class, 113 students are either varsity athletes or on the honor roll. So that's the addition of both. So 113 out of the 200 are either on a varsity athlete or on the honor roll, but they could be in both. So notice there are 74 seniors that are varsity athletes, and there are 51 seniors that are on the honor roll, which makes 125 students. Now, wait a minute. They said there's only 113 students, so there must be some students. In fact, there are 12 students. So what is the probability that a randomly selected student is in both? So there's 12 students that are in both, because again, 125 students over here, but only 113 students over here, which means there's 12 students that are being counted twice. A medical association estimates that 10.9% of the people in the United States have a thyroid disorder. Suppose the medical lab has developed a simple diagnostic test that is 96% accurate of those who have the disorder and 99% accurate of those who not. What is the medical lab gives a test to a randomly selected person? What is the probability that the diagnosis is correct? All right. So 10.9% or 0.109 has the thyroid disorder, which means that 0.891 do not. Now, when you're going to test somebody that has the disorder, it's 96% accurate, which means it's 4% incorrect. And then it's 99% accurate if you don't have the disorder, which means it's 0.0 or 1% incorrect. Now, here's what I want. I want to know that what is the probability that a person is chosen here and it's correct. So here's what we're going to have to do. If I have the disorder and they test me, then those two are correct. Now remember, I have the disorder and it's correct. So that means I'm going to multiply those two together. So 0.96 times 0.109. And so the fact that it's correct is 0.10464. Now, what happens if I don't have the disorder? And again, it's correct. So I'm going to multiply these two together. So 0.891 times 0.99. 0.88209. So now, here's where today comes into play. What is the probability that I have the disorder and it's correct, or I don't have the disorder and it's correct? Because that is an or situation, you would add those two together. And so it's a 98.673. So depending on how you want to write that, or if you want to write it as 98.7% correct. So whether I have the disorder or whether I don't have the disorder, it's got a 98.7% accuracy. Your homework assignment is out of the book. If you have any questions, please make sure it's a short one, which is why we're probably going to do we might do another section today, but if you have any questions, please make sure you talk to your teacher, and good luck.